what's the Lewis structure of COCl2? So to find this out, I'm going to first figure out what the valence electrons are around each of these constituent elements. And then from there, we will see how we're going to have to share electrons to fill the octet of each element. We go to the periodic table, and we see that oxygen is in this sixth column. So it's got 1, 2, 3, 4, 5, 6 valence electrons. It wants 2 more to fill its octet. So we are going to write an oxygen in our drawing with 6 valence electrons. So I'm just going to draw 3 pairs of electrons. We'll start there. Okay, how about carbon? Carbon, I see that it's in the 4th column. It has, to fill its octet, it would need 1, 2, 3, 4 more electrons, so it has 4, and it's 4 short of an octet. So I'm just going to draw 2 pairs of electrons to start with. We'll rearrange the electrons once we do some bonding. How about the chlorines? Well, chlorine is in this row that's 7 valence electrons. It's in this row 17, so it has 7 valence electrons. It needs 1 more valence electron to fill its octet. So I'm going to draw 7 valence electrons around each chlorine. Cl. Actually, I can use the magic of paint to just draw it once and then copy it. So I'll try to do that. I can wow you with my paint skills. Yeah, really exciting stuff here. Okay. So 7 valence electrons, and copy paste. Now I have 2 chlorines. Okay. So if a bond is the sharing of 2 electrons between 2 elements or 2 nuclear systems, how many bonds could I form from a carbon? I could see myself actually making 4 bonds, because I could take an electron from carbon and an electron from oxygen and make a bond, share another bond from oxygen and from carbon and make another bond. I could keep doing this 4 times. So if I took an electron from carbon and an electron from somewhere else, made a bond, did this 4 times, I would end up having 8 bonding electrons, 4 of which came from carbon, 4 of which came from other elements, and it would fill the octet. So that means that carbon can have 4 bonds, possibly. Chlorine, on the other hand, can only really form 1 bond with something. So if, at least under normal circumstances, so as a good first approach to doing Lewis structures, I think of chlorine as basically being terminal, because it can share 1 electron with something else, and that something else can share 1 electron. They'll form a bond, and that's it. Once I've formed a bond between chlorine and something else, I would end up having 1, 2, 3, 4, 5, 6 non-bonding electrons and 2 bonding electrons, 8 electrons total. So that would be it for chlorine. It would have a filled valence shell and wouldn't have any more bonding. With that idea, it's kind of like a terminal cap to any sort of typical covalent system. So if you think about this like Legos, they're like Legos that have you know, like both a male and a female end, and those can be like stacked indefinitely. Apparently, if I can actually get this to work. Right. You know what I mean, right? Then there are also Legos that actually like don't have a male and female end. They just have like either just a female end, or some of them that are like flat and just have a male end. So if you're playing with Legos, you know that you can't really build a chain with things that just have a terminal end, either male or female. You have to have the ability to build multiple connections to have a chain, right? So with that in mind, like these are going to be terminal, these chlorines are. Hydrogen is the same way because hydrogen can only have 2 valence electrons. And if it can only bond by sharing its electron with something else, then one pair of shared electrons is it. That's all hydrogen can really do in a covalent bond. We'll break that with hydrogen bonding, but in general, that's most of the time what we're talking about. So with this idea in mind, it's pretty clear that carbon is probably going to be in the center of this. Maybe oxygen might be in the center. I can't rule it out just yet. We'll do a little math to explore this further. But the chlorines are clearly going to be terminal. So let's do a little bit of math to figure out how many bonds and how many valence electrons total we have. So we're going to figure out, or I guess tally, how many valence electrons we start with. How many valence electrons it wants. And from there, how many bonding electrons we need. And the bonding electrons is just the difference between the amount of electrons that are required to complete octets or hydrogen's duet and the number of valence electrons that are available. So if I look at this system, if I just add up all these electrons, oxygen has 6, carbon has 4, and each of the chlorines has 7. So that's 24 total, right? 7 plus 7 is 14, plus 4 is 18, plus 6 is 24. So there are 24 valence electrons, and we better make sure in our Lewis structure at the end that we end up having 24 valence electrons represented. We want to have each of these elements having an octet of valence electrons surrounding it. So that would mean that we'd have 1, 2, 3, 4 different elements with 8 electrons surrounding them. So 4 elements times 8, that's 32 electrons wanted. The difference of these two numbers is how many bonding electrons there will be. That's 8. So there are going to be 8 electrons involved in bonding. Each bond represents 2 shared electrons. So the number of bonds is 8 divided by 2 equals 4. So we're going to have 4 bonds. I know that each of these chlorines is going to have a bond to something. And I know that oxygen can make bonds. So I'm going to start with carbon as the central atom, and we'll see if that works out. So let's see. Oxygen could share an electron with carbon to form a bond. So I'm just going to draw lines between the electrons to show that they're being shared. There we go. Could actually form another one. Whoops. Okay, so 2 bonds between carbon and oxygen. So at this point, oxygen has 1, 2, 3, 4 non-bonding electrons and 2, 4 bonding electrons. So that's 8 electrons surrounding oxygen. Its octet is filled. So oxygen's done with that representation. Carbon, however, has 2, 4 bonding electrons total and 2 non-bonding. So that's 6 electrons surrounding carbon. So carbon should be forming 2 more bonds. Each bond it forms will give it an additional electron that it shares from somewhere else. That somewhere else is going to be a chlorine. So let me get this a little bit closer. Okay. So what if we take an electron from carbon, an electron from chlorine, and make a bond? And do it with a line so it looks nice instead of a squiggle. Okay. Then that would leave, let me move this electron to the other side. Carbon would have 2, 4, 6 bonding electrons and 1 non-bonding electron. So that's 7 electrons in its valence set. And chlorine would have 6 non-bonding electrons and 2 bonding electrons. So that's 8 for chlorine. So chlorine's done. Carbon needs 1 more electron. Where's it going to get it? It's going to get it from the other chlorine. So here goes. If I just share an electron from each and make a bond, then I would end up having that structure. And this structure works. So all the octets are complete. This carbon has 8 bonding electrons around it, so it has a complete octet. All the other elements have a complete octet. For some reason, I don't know, there's some sort of aesthetic to this that I don't understand. So for artistic purposes, I'm going to make it look symmetric with the lone pair of electrons on the oxygen. It's probably good to do this if you have an exam or something, this way that your grader will not get confused. So let's take a look and make sure nothing's crazy is going on. So our math told us we need 8 bonding electrons. Here we have 4 bonds. Each bond has 2 electrons, so that's 8 bonding electrons total. That checks out. Our math told us that if there's 8 bonding electrons and we started with 24 valence electrons, that means that the remaining 16 valence electrons are involved in, or sorry, are not involved in bonding. They're just hanging out as lone pair electrons. So let's see, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that works out too. So the number of non-bonding electrons makes sense. And finally, all these elements, as we said before, have their octets filled. So this is the Lewis structure. If I was to try to start with oxygen as the central atom instead of carbon, I would have run out of bonds that I would have been able to use. So if I had like something like chlorine, oxygen, carbon, chlorine, this carbon needs to have 4 bonds to fill its octet. But it'll only be able to, in this scenario, make a bond to chlorine and make a bond to oxygen. The oxygen won't be able to do any more bonding to carbon because it already is bonded twice. I'm leaving out the lone pairs just to make a point here that you need to have the carbon in the center to have the desired connectivity. It's actually probably a good idea to start with carbon in the center of stuff. That's usually going to be the more reasonable structure. Sometimes the molecular formula will hint at how the structure is supposed to be formed. So for example, if you see a structure like H3C COOH, this structure is implying that these oxygens are going to be bound to this carbon, and that this carbon has 3 hydrogens attached to it. So they're giving you a hint as to how this molecule is organized and how the bonds are ordered.